See it that couldn't make it? Wow, things are slow today. All right. So my name is Mike Hitchcock. I am with Acorn Petroleum, as a lot of you people probably do know. And we're going to be, again, talking about basic hydraulics, how to keep them running well. If you have any questions, let's probably just save them for the last if we can do that. A lot of people, I always like to start with a little story here and there on a lot of our meetings that we have. And a lot of people don't realize where the name Dello came from. And back before World War II, all the diesel-powered submarines that went out to sea, every time they came back from a patrol, they had to have the diesel engines rebuilt because there were no compounded diesel engine oils at the time. And basically, Standard Oil, which is Chevron, came up with a product called diesel engine lubricating oil, and it was specifically designed for Caterpillar engines. It was sold to the United States Navy as a possible solution for their failures at sea on the diesel electric boats. What they found out was the Navy started ordering it because they liked it. It was working. The boats were coming back from sea or from patrols and not having to have their engines rebuilt. So the Navy started ordering it, and they started ordering the stuff called Dello, which Standard Oil didn't know what that really meant. So they asked the question, "What is Dello? What are you asking for Dello?" And they go, "Well, diesel engine lubricating oil." And the Navy likes to put an acronym for everything. So in 1941, Chevron / Standard Oil applied for a trademark for the word Dello, and that's where that came from. So it was the very first fully compounded diesel engine oil, and they have been a leader in that world ever since. So let's go on with basic hydraulics. The story of hydraulics goes back thousands of years. People have been using water, which is a form of hydraulic power, for eons to power mills, things along that line. The Romans built aqueducts, which brought water in from the mountains. Basically, these aqueducts had troughs that had water traveling at less than a degree of drop for miles, and they powered their flush toilets that they had. All their fountains and things along that line in Rome were all powered by hydraulic power, and we even use it still today. This is a little cider mill that used to be a grist mill in my hometown where I grew up, and it's still in use today, still water powered. Basically, the definition of hydraulics is it's contained fluids under pressure become a solid. So we're using a flexible solid to move things. It transmits power in various areas in any direction, and then we can multiply power with it. And a single source can power multiple devices. And it's a lot like a lever. We can take a little power and turn it into a much more powerful tool. So the primary function is to transmit and control power, and it simply converts mechanical power from a pump into fluid power, and then back at either the motor or the cylinder or whatever form of mechanical power we want, it transmits that back into mechanical power. The fluid has to lubricate the parts and protect them from wear and reduce corrosion and rust. One thing that's constant about hydraulics, regardless of what you're doing with it, is it transmits power in every direction the same way. So if you're putting 1 pound of pressure against a cylinder, there's 1 pound of pressure in every direction. If we take that 1 inch or 1 pound of pressure and basically take that and say we're going to put it against a 1 inch square piston, as the powering device. The work, if we have a 10 square inch piston on the work side, we get 10 pounds of force. It multiplies the force. So that, but it maintains the pressure. The pressure stays constant. So we still have 1 pound of pressure, but it's now doing 10 pounds of force on the other side. Fundamental hydraulic circuits, you basically have a reservoir to hold the hydraulic fluid. You have a pump that converts the mechanical energy into fluid energy. We have valves that control the direction, and we can shut off or control the flow and power with control valves, and with directional valves we can control the direction of the power, and whether we either go forward or reverse or change the direction of a cylinder. So basically, that's it in a nutshell. The only other piece that's in there is a pressure relief valve, which when there is power being supplied against the system and it doesn't have anywhere to go in the work side of the system, it just diverts everything back into the reservoir so that it gets recycled. So let's go to the various components that are involved in this. We got the reservoir, which basically holds the spare lubricant, and it allows the fluid to rest, and it cools the fluid. The fluid is allowed to release water, contaminants, and air that gets entrained in the system. It just releases that into the reservoir. We calm the oil there. Then, it needs to be kept clean. The reservoir does need to be kept clean because it does drop the water, and the water needs to be removed from the reservoir. And we also need to keep the air, as the changing pressure inside the fluid level in the reservoir itself, it either brings air in or lets it out. So we need to desk case that so that it's kept clean. Reservoir itself, basically they come in all shapes, sizes, but the basic components are about the same. You have an air filter, hopefully. You have a suction line or an outlet and an inlet for the hydraulic fluid flow. You have a clean out plate. You have a sight glass to see what the level of the hydraulic fluid is inside the tank. And it's nice to see what the color of the fluid is, if it's starting to degrade and whatnot. You have a place to fill the fluid. Hopefully there's a baffle inside the reservoir, and you have a drain plug. One of the things about it, I go into a lot of shops and I see absolutely, on the exterior of the reservoir, they're just filthy in a lot of areas. Well, dirt gets in, regardless of what you do to try to keep it out. They should be kept clean. Try to keep them as clean as possible. Check the drain for water every single day. Check the sight glass for fluid level and appearance, like we mentioned earlier. The reservoir itself needs to be, inside the owner's manual, there's probably a requirement for the reservoir to be cleaned on a periodic basis. And when you have downtimes, that might be something to think about. Cleaning out the reservoir, making sure there's no debris or anything along that line in there. Put a desk case filter in place of the breather so that you're keeping the air in there dry and clean. And ensuring that you have the proper size tank for your system. Most OEMs take care of this for you, but in a lot of cases we see if you're having problems with wear or premature failures in certain areas, it may be nice to find out whether or not you have the right size tank in there. We're seeing a trend in the mobile equipment to reduce the size of the reservoirs to save on weight. But the rule of thumb is whatever the discharge rate of your pump is, then it should be somewhere between 3 to 5 times that for the tank capacity. So in this example, if you have a 5-gallon pump, you need a 15-gallon reservoir at a minimum. This is a illustration of the dust case filter. Air comes through. There's a filter in there to clean out dirt and debris, and then it goes through a media that absorbs the water vapor. And that's important because it does keep everything nice and clean and keeps your fluid dry. The next part of the hydraulic component is the plumbing. It's how the fluid moves through the system. There are parts and pieces that can be put into the system that can cause cavitation, and we'll talk about that. Hoses can wear out, they can oxidize. The fluids, when they become more acidic and things along that line in the system, can start eating against the rubber hoses and the parts and pieces. And then we have leaks that can occur that can cause contamination of the fluid itself. So we see the hoses inside, most all hydraulic systems have hoses. As the fluid oxidizes, it does tend to work against those kind of products. And that's where we see hoses that break for no apparent reason whatsoever. And then the hydraulic system becomes a sprinkler system. We've seen that. Most people who have worked around hydraulics have seen it. It's something that happens on a regular basis, and it's something that can be prevented just by doing some simple maintenance and keeping track of your coolant or your fluid in while it's being used or in service. We see a lot of cavitation issues where that causes more pump failures. And from my standpoint, that's the one thing that I say it's the most preventable thing that you can do is to look for cavitation inside the system. It's pretty simple. You see constriction points, things along that line. There might be fittings that cause a constriction or whatever. Those all cause entrained air to become bubbles, and those cause cavitation, basically, which is an erosion inside the system. We'll talk about that in a little bit, but what basically you have is a system at rest. One of the ways to find it is when the system's at rest, or when it's on pressure or on the pressure side while it's running. If you see leaks, those are typically areas where air and dirt can get in. We've all seen those fittings on hydraulic systems where they're just caked with dirt. Well, that's because the fluid's leaked out. Dirt's been introduced to it, so it becomes a kind of like a little hydraulic dirt mud pie. That's an area where dirt and air are getting into the hydraulic system itself. And what we see is, especially on the vacuum side of any hydraulic system, we see the fluid moving through there, and it's moving through basically at a vacuum, because on the other side of the pump it's positive. Well, on the vacuum side of the pump it's going to be a negative, and it's going to draw air in through those leaks, and that's going to cause an erosion action directly against the pump. So those are things that we need to watch for. And what is cavitation? It's basically an air bubble that explodes against a surface. And we see it it's really prevalent in like water pumps on engines and things along that line. You'll see water pumps that look like they've eroded from the center out. Well, that's just cavitation. This also happens with hydraulic equipment, and you'll see pump failures, things along that line, because there's a cavitation action against the moving parts inside the pump, and it looks like a rust action in and of itself. It looks like a corrosion, and it is corrosion, but it's very, very preventable. We just look for leaks, and we have a situation where I was called out to a situation where we had a piece of hydraulic equipment where behind that arrow is actually the hydraulic tank or the reservoir, and it was at rest. The pump was off, and it was dripping basically right there. And you can see that there was telltale signs of the leak all the way along this railing here, and they just said, well, it's on the hydraulics tank side, so There is no way that air could be introduced into that. Well, it is. It's basically right now, when the pump's off, you turn the pump on. Now you're working at a negative pressure side of the pump, and it is actually drawing air in. And you got a hydraulic tank there that's really just putting some pressure against it, but not much. And you are sucking air into that. And we knew that as soon as we turned on the pump, because as soon as the pump turned on, we waited 3 minutes, and you could hear the gravel sound going through the pump itself. And what that was air bubbles, and they were causing erosion against the pump. So I like to, when I'm talking about equipment, I usually bring in a physical or human body type um, attribute into it, because our bodies are just nothing more than machines themselves. But when you have a cut finger, what do you do? Do you do nothing? Do you rub some dirt on it and get going, or do you clean it and bandage it up? Well, obviously it makes sense to clean the cut, bandage it, which is basically sealing it up and protect it from infection. It wasn't long. It was back in the 30s, as late as the 30s or early as the 30s in our history. A cut like this was, in some cases, a death sentence for many people. There were no antibiotics. There was no way to prevent infection. They were taken very seriously back in those days. There were a lot of people that had amputations. You have to look at a leak in a hydraulic system as a potential way to infect the system. So keeping dirt out and letting the machine clean itself is the most cost-effective way to reduce failures and to reduce costs. You got to treat leaks just like the cut finger, clean it and seal it, tighten the fittings, repair the equipment, do what you have to do, replace parts and pieces, whatever you have to do, because that's the only way you're going to keep the fluid in it clean and dry. And it absolutely makes no sense to put perfectly clean oil into a leaky system. And that's because all it's going to do is contaminate it in a few days of operation. And then it's going to become part of the problem, not part of the solution. So what do? We look for and correct leaks. Dirty fittings, puddles, those are all telltale signs that we have a leak. Listen for noise. The best thing you can do is just listen for gravelly noise, gravel or marble noise going through the plumbing. That's air. That means you have an air leak in the system. Or just noises in general coming out of the pumps and that sort of thing, because you could have some sort of intrusion problem, some dirt problems, or it could just be self-destructing. And keep track of all your past failures, pump failures, valves, things along that line. If you know you have a problem, you might want to look to see where it's coming from. Why is it a problem? Next stop in our hydraulic components is filtration. And the filtration cleans the service lubricant while it's working. At a minimum, it needs to be filtered at least one point in the system. It should be filtered in 2 locations, and the more the merrier. The more places you have filters, the better chance your equipment is going to stay cleaner and operating at its peak efficiency. This is an ideal system where we have a suction filter on right before the pump, so the pump is getting some filtration before the fluid hits it, and then the high pressure filter on the other side of the pump before the valves get hit by any contamination or anything along that line. And then after everything's done its work, well, we've got a medium pressure filter on the return line, so that the fluid going back to the reservoir is being filtered one last time. What we see is in a lot of cases, we see filtration happening at the exact end of its journey through the whole system. So everything is being filtered on the return side of the hydraulic system. It's not very efficient to do it that way. It may be what what manufacturers recommend. I always like to filter prior to the pump. That's the thing that's the most susceptible. It's the second most susceptible to damage from dirt, and it's the easiest place to usually plumb something in. Another scenario where you have something on the just after the pump going to the valves, which are very, very sensitive, and one on the return side. So what are we looking for and what are we afraid of? Well, really it's dirt. And it's just simplified. We have dirt particles that are, if they're small enough, they go through and do no damage whatsoever to the system. In best conditions, we still get large chunks that cause welding damage or cause scarring inside the system. And what are we really talking about? Well, how big is a micron? The definition of a micron is it's 1/1,000,000th of a meter. It's very, very small. We're looking at bacteria is 2 micron. Blood cells are 8. The human hair is around 50 micron. So when you look at the bottom level of where we can see, it's around 40 to 38 micron. Everything, we're really talking about stuff we can't really see. So because we can't see the danger below 40 micron, we need to be using, some sort of testing procedures. We actually have to involve some systems or laboratories to help us determine what our cleanliness levels are. And, it helps to partner with a company that understands what setting up these systems are and how to set them up properly. Develop a monitoring system that has buy-in from all levels. And you need to put together a system that everybody from the top down, from the owner to the worker bee, appreciates and understands. And everybody has to buy into the whole system. Otherwise, it doesn't work. And work with qualified laboratories that have OMAs on staff that can help you through the process. Where do you start? Laboratory services. It really starts and ends with a good lab. It really does. You need somebody, again, I mentioned this earlier, OMA 1 minimums, CLSs or OMA 2s. And there are other certifications, the MLTs and the MLAs and the CMFSs. Those certifications are very useful too, and depending upon what industry you're in. Do not work with a lab that doesn't have an ISO 17025 certification. I mean, if they haven't done the work to prove that they know how to document everything that they do so that you can go back and check what you're working with and have procedures in place, it really does help make your life a little bit easier when they have those certifications in place so that you know that they know how to, they've documented procedures for everything that they do. They should have online services so that you can at least get the results back quickly. It does you absolutely no good if they mail you the results because you already mailed them the sample. That could have taken several days to get to them. If it's around Christmas time, we just got a Christmas card about a month after it was mailed the other day, so that becomes a history report at that point in time. Online services help. It speeds up the whole return of the information to you. They should have training and support. They should be able to get, have online training or in-person training to help you. Phone support and local representation is very, very important. And what's in it for you? What does this really mean? Well, there are these things called life extension tables, and this is one of them that I use. And if your cleanliness level comes back from the lab from the testing that you sent in at 2219, which is a measurement of how many particulates and what size they are inside the system, and you want to get to, or you're able to reduce the amount of particulate in your samples down to 1714, well, then you just increase the the life of your hydraulic systems by 4 times, which is going to pay for the entire program and then some. So this is where the rubber meets the road, right here, is by doing all these things, keeping things clean, working on your cleanliness levels, working on procedures to make sure that everything is repaired properly, put back together properly. It makes the equipment last longer. And the filter requirements, you know, they're measured by micron ratings, efficiency, and beta ratings. If you ever took one apart, this is what one looks like on the inside. They're not that glamorous, but they do a lot of work. And there's every piece in here has a purpose. And what we really look at is you know, one of the things that I want people to understand, filters that have been left on too long and have clogged to a point where they no longer can filter, well, then the filter probably goes to bypass. So all you're doing is just recirculating dirty oil. There's no way to really, unless you have an indicator on your filter housing, there's no way to tell if that's what's really going on. But taking the time to make sure, putting dates on your filters, making sure you're doing the proper maintenance requirements, because filters do have maintenance requirements. They do need to be changed. This helps ensure that you don't go into a bypass situation and you're just recirculating dirty oil. On the filter ratings, the one that we hear a lot of is the beta rating. Is it basically what is the beta of the filter? Basically measures the amount of particles prior to the filter and what comes out of the filter. And it's the ratio of particles that are caught by the filter. There's a lot of different things that we talk about in ratings. There's the nominal rating. The nominal is really just an arbitrary number, doesn't mean much. What we really want to look at is the absolute rating. So if it's a 7 micron absolute, then that means that nothing bigger than 7 micron is going to go through that filter. And the beta rating does measure the overall ratio of particles going through the filter. So we see a lot of beta 1000s, which is, it's 99.9% efficient. So out of 100,000 particles that are upstream from the filters, only 100 are getting through. So that's tells you a little bit about what the efficiency of the filter is, and that's what those numbers actually mean. And those are all typically spelled out in the owner's manual, what the OEM is looking for to keep the equipment running at its optimum efficiency. You'll find the recommended lubricants, the recommended filters, what the service intervals are, and what you have to do to maintain your warranty. Those are all spelled out inside the owner's manual. Machines are designed to clean the lubricants to a desired cleanliness. That's what they're designed to do. They all have filter systems on them. They weren't put on there just as to make everybody's life miserable. They were put there for a reason. And they're put there to keep everything at a desired cleanliness. They fail when we let leaks and things along that line enter into the system, and we let dirt intrude into the system uninvited. We need to follow the recommendations from the manufacturers regarding filtration. There are minimum requirements usually spelled out, and filter change requirements. Partner with qualified professionals to design testing and evaluation programs, which would be a laboratory and things along that line. Evaluate internal handling and maintenance protocols. It may be something that you're just doing, you're introducing dirt into the system because of something that you're doing and totally unaware of it. Or there may be something that just by adding an air filter to a bulk tank or something along that line, you can eliminate dirt and water from entering into the system. The pumps. It's another part of the hydraulic system is the pump. Components that create the power. Basically, it's all it is. It's something that creates the power. It turns mechanical power into fluid power. They are susceptible to contamination damage. cavitation, dirt, water, all those things lead to failures in pumps. There are basically three basic types of pumps. There's the gear pump, vane pumps, and piston pumps. Vane pumps have significantly more power than gear pumps do, and piston pumps are more efficient and more expensive than all of them, but produce even more power. Basic gear pump is just that. It's a basic gear pump. It usually works with a fixed volume. They're very, very inexpensive in comparison to everything else that's out there. Most owner's manuals will tell you that under 1,000 psi you don't need anti-wear. I'm not a big fan of that. I think anti-wear is because it is a gear pump and it's got sliding action. You should use some sort of anti-wear element in the fluid. Basically, there's a scrubbing action that's going on inside the pump. And anytime you have scrubbing action, you need some anti-wear in there to help prevent that. Vane pumps, well, they basically are a centrifuge and move fluid through and compress it in that fashion. They're very efficient. They don't, as long as they're maintained well, they don't leak, and they seal very, very well. That's usually the only thing that really can go wrong with them is the seals themselves, and they do produce a lot of power. Axial piston pumps are very susceptible to dirt intrusion. They can produce a lot of power and have basically you can be the ones with adjustable swash plates can actually change the amount of action and things along that line or direction of the fluid flow. Very, very complicated, very, very expensive. Radial piston pumps work on the same process, but they work in one direction and are again work are very, very susceptible to dirt damage. Filtration becomes very, very important with these. We talked about cavitation. In gears especially, we see cavitation working where you see collapsing bubbles that are entrained in the air in the fluid itself. They stick to objects, get pressed up against that object, and explode. And it basically causes a cavitation event. Back to the components again, the relief valve. It is a critical, it's a safety device, so that if the pump is running but there's no work being done, basically the valve opens up, everything dumps back into the reservoir. So it does prevent an overpressure situation which could cause a problem, or in some circuits where the pump is just running all the time, it's something that's activating all the time. Again, we talk about the circuit. You can see that the relief valve is in a closed circuit basically between the gear pump and the reservoir. So it does fulfill a vital function there. Control valves control the direction of the fluid power. They're highly susceptible to contamination, and they're expensive. Basically, they work on very, very tight tolerances, and with one pull of the lever, you can change the direction of the equipment, the valve, the cylinder, the motor, whatever it is that you're working with, very simply, just by changing the direction of the fluid with one valve. They work on very, very tight clearances. They're typically in the 1 to 8 micron range, depending upon what type of valve it is. They're very, very, and they are excruciatingly susceptible to dirt. That's why we always like to put a filter before that, so that we can catch that any kind of contamination before it gets to these components. The motor uses the product of the fluid power. So it turns the fluid power into work. So basically converts all that fluid power back into a mechanical power scenario. There are various types, and they're all usually very expensive. We see pistons, we see motors, drive motors, directional motors, things along that line. Those are all very easy and simple ways of putting together a system that doesn't require a drive shaft or something along that line to power. See that on tracked equipment where we have one engine driving a hydraulic pump, and that hydraulic pump basically pumps everything. It powers everything in the system. So it becomes a single source for everything that's done with the equipment, from the boom cylinder, stick cylinder, the final drive, the swing, and the travel motor. All those things are done with one hydraulic pump and one source. We get to the lubricant. And that's what I like to talk about is lubricant. The primary function is to transmit and control power. It lubricates the parts from wear, rust, and corrosion. Every piece of equipment has some sort of recommendations for what fluid is required inside of it. And we see this. This is it actually spells everything out in Seybold Universal System, but it also calls out Stokes. So we can look at it and say, okay, this is a 22 RNO with an anti-wear. So this is what they're looking for this piece of equipment. The single most important aspect of any fluid is its viscosity. Viscosity is resistance to flow. It's the single most important element of any fluid. And if it's too high for that piece of equipment, it leads to cavitation, leads to, the equipment isn't operating properly. You need more power to run it. It causes more friction, which is heat, which causes more failure in the fluid itself, which causes it to thicken more, et cetera, et cetera. It's a horrible situation to be in. If it's too low, now we get too much wear because parts and pieces are touching one another. There's nothing separating anything. We get some seal leak, seal failure and fluid leakage. Another thing that we talk about, and you'll hear people mention a lot, is the viscosity index. And the viscosity index just really is a way of talking about or expressing the range of temperature the fluid is designed to operate in. So the higher the viscosity index, the better the range of operation it can work in. So it can work in much lower temperatures and much higher temperatures. It gives you better flow at lower temperatures and gives you strength, separating capability at higher temperatures. So it's a good way to provide a measurement that tells you if the fluid works for your scenario. If it's inside a plant, temperatures are pretty stable. You may not need something with as high a VI as something like a piece of equipment here in Colorado, where we have temperature swings of 40 to 50 degrees every day. You may want a higher VI fluid. And those are all things that we can, those are discussions that we usually have with our customers when we're interviewing is what's the environment we're working in? And we ask those questions for a reason, because it does help us with the recommendations. Talking about efficiencies, we look at how inefficient hydraulic systems really are. We do have metering losses. We have actuator friction line losses. We have pump losses. There's leakage in the pump. And at the end of the day, most fluid, we get 14% useful work out of the fluid. The better the fluid, the more useful work you get out of the fluid. which comes to the fluids that we typically sell, which almost, well, without exception, every hydraulic fluid we sell, um, if it's a mineral oil hydraulic fluid, is a Group 2 oil. It's hydrocracked, it's pure, it's water white when it comes out of the refinery. There's less sulfur in the fluid itself, so that it doesn't self-destruct and become more acidic, which causes, because heat and water mixed with sulfur, creates acids. We want to eliminate as much sulfur as possible. Group 2s typically have zero, or as close to zero sulfur in them as humanly possible. And the proof is in the pudding. You look at the base oils. Group 1 base oil has got a yellow tinge to it because it's got sulfur in it. It's been chemically de-waxed. Group 2 oils have been hydrocracked. They have no sulfur left in them. So we use highly refined base oils. We use advanced additive technology to work with those highly refined base oils because it does take a little extra finesse to make them work. And that gives us our IsoSyn technology. Where we see things going. More off-highway emission standards have become more strict, lower sulfur, exhaust emission controls. We've seen that for years. We know that's happening. It's happening now. It's going to continue to come down the avenue. And a drive for better fuel efficiency. By using better fluids in the hydraulic system, we get better fuel efficiency. And we can go to extended service hours, which we see in a lot of our fluids that we use out there in our hydraulic fluids. We're seeing anywhere from 4,000 to 8,000 hours of life in our fluids because they just last longer. So what oils do we offer? We offer Chevron Rando HD, which a lot of our customers are familiar with. It's a phenomenal oil, and a lot of our customers really enjoy it. It reduces the oxidation, things along that line in their lines. They don't, we've had customers that have left us and gone to another brand and all of a sudden had failures because of oxidation. Rando doesn't oxidize very, very easily. HTZ it's more synthetic. It gives us a better temperature operating window. We have MV, which again is a multi-grade oil. Chevron Regal, which is an RNO. If what your recommendations are from your OEM are an RNO, we have Regal. It's a very, very fine rust and oxidation oil. GST. We have some situations that call for GSTs. There's several customers that use GST as a hydraulic fluid. If you have an older piece of equipment, it leaks like a sieve, and cleanliness is not a big issue, and you don't have time to repair it, and you don't, AW46 might be what you're looking for. That might be what you need to use. If environmentally friendly products are on the list, Chevron Clarity, which is a readily biodegradable fluid, and it works very, very well, and it has a very, very good track record as far as protecting equipment and improving uptime. Tractor hydraulic fluid, we have Chevron THF, THF 1000, and our regular tractor fluid. Both of them are fine products. They both work very, very well. They meet all the J20 requirements. We have food grade hydraulic fluids that are available. We have fire resistant hydraulic fluids that are water glycol based. And we have other environmental consideration hydraulic fluids that have U.S. Coast Guard approvals, et cetera, that are available to us. So we have, basically, if you have a hydraulic system, we definitely have a solution for you, one way or another. Because you're not buying lubricants, you're buying reliability from us. And that's what we believe in, not letting our customers fail for any reason. So we do talk to our customers about what we can do to help them not fail. Shear stable, high efficiency hydraulic fluids that give us startability at very, very low temperatures, all the way up to 140 degrees Fahrenheit. These are very, very important because you want to be able to maintain the same amount of power capability throughout the entire day and not have the oil give out on you halfway through a shift. Talk about the VI in oils. Well, it basically is when you see charts, you'll see a flatter line for higher VIs, which means it covers more temperature areas and gives you a better temperature operating window. And that's what we're looking for. Again, we talk about clarity. It's ashless. It doesn't leave any trace. It doesn't have zinc in it. It doesn't have any heavy metals in it that are going to pollute the environment. Non-ashless oils, we have the Rando HDZ and HD. Those are, depending upon what you're looking for as a solution, we have those for you. You hear me say oxidation. It's accelerated by introduction of air, heat, and other contaminants, metals, things along that line. The viscosity increases, becomes more acidic, forms sludge and deposits and varnishes, causes a lot of issues. Thermal degradation is, by heat. It's exacerbated by the metals and other contaminants that are in there. Again, increases the oil viscosity, acidity, sludge and deposits. You're going to get varnishing on your equipment, things along that line on surfaces. So how can we help? Well, we have our QC 101 survey. We go through, we look at your operation from top to bottom to see what kind of products you're using, if there's any potential for consolidation or upgrades, or maybe you're using something that's more than you need. We can talk about that. We can talk about setting up laboratory testing, protocols, programs, things along that line. We can look at how you're handling your fluids and what we can do to improve the overall life cycle of your equipment. And we do this at no charge. We do these things at no charge. So if there's something that we can do for you, please let us know. That pretty much covers the scenario. Didn't know if there was any questions or anything along that line that anybody had. No questions. None. Okay. I'm that good. I am that good. I explain things so well that nobody asks any questions. Very good. I guess that pretty much ends the pro. I try to keep these down to an hour. Did everybody get anything out of this? Was it interesting, informative, and?
Yeah, thank you. It's always good information.
Okay, well, I appreciate it. Okay. If there's any topics that you guys want us to develop or anything along that line, I do have this year all pretty much planned out. But if there are topics you'd like us to cover, please let me know.
And the great thing is that we're recording this, so we'll be able to, like, if you guys want, we can go ahead and send you a link to the recording. If you want to watch it again, if there's certain parts you want to review again, it's certainly available for you.
Yeah, that would be helpful.
Well, thank you very much, guys. And look forward to hearing from you guys soon.
All right, thank you.
All right, thank you.
Thank you very much. Very informative.
Thank you.